Could aliens have visited us? The distances in space are so vast that they lead to what is called the hierarchy problem. Why is the subatomic scale so small while the cosmological scale is so large? We'll delve into the possible causes of the hierarchy problem in another video. But in such an expansive universe, even identifying places you'd want to visit, let alone getting there, is extremely challenging. Let's say you've identified your destination. How would you reach it? The fastest spacecraft humanity has ever built, the Parker Solar Probe, achieves a speed of 330,000 miles per hour. With this probe, forget about traveling from one end of the universe to the other. Even reaching Pluto would take over a year. And we struggle with the 6-month journey to Mars, facing numerous psychological challenges. But the issue isn't just staying within our system. Pluto's distance from us is not even as significant as the nucleus of an atom in comparison to the universe's vastness. Look, the Parker Solar Probe speed is only 0.05% of the speed of light. At this speed, leaving the solar system would take over 3 years. Reaching Alpha Centauri, the star closest to us after the Sun, would take 9,000 years. 9,000 years ago, the Neolithic Age was just spreading across the world. Mammoths were still alive, and there weren't even Egyptian pyramids. And there's no guarantee of finding life even if you reach Alpha Centauri. After all, life isn't necessary around every star. Life could exist anywhere within the observable universe's 93 billion light-year expanse, or even beyond what we can observe. Let's say we detect signs of life, like signals, not around Alpha Centauri, but around the black hole HR 6819, 621 quadrillion miles away. Suppose we want to go there. Traveling there with a spacecraft like the Parker Solar Probe would take 2 million years. 2 million years ago, the genus Homo was just beginning to evolve. We can't even guarantee our civilization will exist in 2 million years. We're only talking about 621 quadrillion miles here, which isn't even a significant distance in universal terms. But understand this. Our modern technology doesn't even come close to enabling reasonable space travel. Here, our sci-fi instincts kick in. Well, then, let's not go at 0.05% of the speed of light, but at 100%. If Einstein's theory of relativity, which has passed thousands of rigorous tests, is correct, this is impossible. No object with mass can reach the speed of light because it would require infinite energy, which doesn't exist in the universe. Fine, let's not travel at light speed, but at 95% of it. This is very hard, but not impossible. The difficulty comes from this. You need something to accelerate your exploration team and all experimental equipment to 95% of the speed of light. That's 621 million miles per hour. Currently, we achieve this by burning fuel. As the fuel is expelled from the rocket's rear, due to the conservation of momentum or Newton's action-reaction law, it propels the rocket forward a bit. Thus, our rockets can gradually accelerate. But to accelerate a rocket already moving at extremely high speeds, you need increasingly high quality or quantities of rocket fuel. But more fuel means you must propel a larger mass. So, as you increase the fuel, you have to increase the fuel to carry that fuel, leading to an infinite loop. Hence, there are limits to fuel quantity and rocket size, or we'll burn increasingly efficient fuels, which we don't even know yet. For this, we might think of alternative technologies like ion thrusters or solar sails. Ion thrusters work by ionizing noble gases like xenon and accelerating them through an electromagnetic field. Currently, the force ion thrusters can produce is about what you need to lift a sheet of paper. Solar sails aim to accelerate by harnessing charged particles from the sun, much like sails use wind on Earth. These are nice concepts, but might need hundreds of years of research to become functional. They might work one day, but not today. There are also more absurd sci-fi methods. Warp drives, Alcubierre drives. Rather than accelerating the craft, let's bend the space-time fabric in front and behind it using exotic matter with negative energy density or dark energy, whose existence or nature we're not sure about. But we're very, very far from practical implementation. However, if we want to go to very distant places in meaningful timeframes, we seem to need something like this. A nice consequence of approaching light speed is that time for space travelers slows down compared to someone on Earth. For someone traveling at 95% of light speed, 1 second feels like 3 seconds on Earth. But as I mentioned, we have no idea how to reach these speeds. Our technology is still laughably primitive. Therefore, missions to far distances require absurdly long and beyond human organizational capabilities planning. There's also a sociological aspect. For instance, if a mission takes 75,000 years, how do we coordinate this? We live in a world where the political atmosphere can change within a year. How do we ensure political, economic, and societal stability over such long missions? Or how do we communicate with these missions? Communication signals can't exceed light speed. So, if we say hello to a mission 5 quintillion miles away, it would take 34,000 years for the signal to reach them. Their response, "Hello, how are you?" would take another 34,000 years to come back. I'm not even considering additional distance due to the universe's expansion, or that missions traveling near light speed would receive signals from Earth even later than 34,000 years. Under these conditions, how do we coordinate missions? We can't. Realistic space travel can't be about suddenly jumping from point A to a point B thousands of light years away. Instead, a civilization would need to spread like cancer to reachable points, establishing bases. This brings up an interesting point. The signals from such a widespread civilization would be more extensive and easier to detect. Meaning, the first intelligent extraterrestrial life we detect would likely be a highly advanced civilization spread across its system or galaxy. But there's another problem, the cuteness problem. If we pause to consider our self-assigned value, we might realize how adorably foolish we are. We still think the entire world, the entire universe, revolves around us. For example, when talking about extraterrestrial life, we assume their intelligence would be on par with ours, functioning similarly. Yet, on Earth, different forms of intelligence already exist, looking and functioning very differently, and we don't even care about them. Neil deGrasse Tyson explained this legendarily. Here, I'll remind you of it. He says, let's define intelligence by what makes us unique. Let's say intelligence is the ability to create poetry, symphonies, art, math, science, etc. Let's say for a moment that this is the definition of intelligence. Of course, many different definitions could be made. Chimpanzees can't do any of these. Yet, 98.77% of our genes are exactly the same as theirs. The smartest chimpanzee can at most use a little sign language, something even tiny human babies can do. What worries Tyson deeply, according to him, is this. Everything we have as humans, everything that separates us from chimpanzees, comes from that 1.23% difference in our DNA. Maybe building the Hubble or James Webb telescope isn't that much different from connecting two fingers to communicate in sign language. We just keep telling ourselves the difference is enormous because we're a species that thinks anthropocentrically. We're fooling ourselves, overestimating our value. Imagine an alien from another planet with DNA just 1% different from ours. Let that 1% difference be in our favor compared to chimps. If that 1% difference allows us to build the Hubble, add another 1% to that. What would we be compared to them? We'd be nothing more than drooling, foolish primates in their eyes. Imagine if we brought a genius like Stephen Hawking before one of their primatologists. They might say, "Look at this one. It can even do astrophysics by heart. How cute! Our little Johnny can do this too. Don't we treat chimps this way?" It's odd to think such an intelligent species would care about us. Because, as I said, there are hundreds of thousands of species on this planet with different intelligences. How do we, the smartest among them, treat them? In one word, indifferently. While developing our civilization, do we think about the ants, squirrels, birds, or chimps whose homes we destroy? We don't care at all. What they think or feel, we don't even bother. Yet, many of these animals are only a few percentage points different from us. Assuming an alien civilization would care about us is based on the assumption that the maximum intelligence that could evolve in the universe would roughly match ours. This is an incredibly foolish assumption. If there's a civilization advanced enough to reach us, their likelihood of trying to communicate or care about us would be no greater than our effort to communicate with ants or chimps. They would probably see us as ants in their way while expanding their civilization, digging tunnels on our tiny planet. Just as we don't care about ant colonies when building a skyscraper, they likely wouldn't care about us while constructing their galactic empire. We must remember this. As you can see, the problems are endless. But of course, we could solve all these issues with some magic. Maybe general relativity is false. Perhaps the speed of light can be infinitely surpassed. Maybe teleportation is child's play. Perhaps locality, determinism, causality, etc. are all nonsense. Maybe somewhere out there are super, incredible technologies that make traveling from point A to B in the universe as simple as blinking. Maybe the highest intelligence possible in the universe is ours. Yes, we can imagine universes where all these are true. Maybe aliens have overcome these issues with technology beyond our wildest dreams. However, there's no observational or scientific data to suggest they can do this. It's possible to think they could do all this through deductive reasoning. After all, our technology might seem incredible or incomprehensible to chimps or ants. But chimps see us, experience us, they have direct and objective evidence of our existence. We have no such evidence for this hypothetical uber-civilization. Not yet. In science, we don't assign a 0% probability to such wild possibilities. Understand this well. We just give a higher probability to hypotheses based on objective data than to those based on fantasies, and we ponder more on those. Those who want to believe in these fantasies see this as narrow-mindedness. But then they go and make assumptions that ignore known facts, trying to convince people, more importantly, scientists in the field, of their claims. If you make comments lacking in basic knowledge of physics, chemistry, biology, you can't expect the experts to take you seriously. If you're going to propose a hypothesis worth considering, you must ensure your claim doesn't contradict basic scientific truths. And remember, what we don't know today might unlock amazing discoveries tomorrow. Yes, this is almost guaranteed. But you can't use what we don't know today as proof for what we might discover tomorrow. If you do that, you've fallen into a logical fallacy known as the appeal to ignorance. The absence of evidence is not evidence of absence. Yes, something might exist, but we haven't yet found evidence for it. But there's more to that saying. The absence of evidence is not evidence of absence, but it's definitely not evidence of existence. Never forget that. You can't use the lack of evidence as evidence of existence. If you have a positive claim, like the existence of alien civilizations, the burden of proof is on you. If you can't provide evidence for it, the other side doesn't need to prove your claims false. If we understand this, in many modern-day debates where we unnecessarily fight, we can learn to say, we don't know yet, and take steps towards knowing. Is there life beyond Earth that's as intelligent, or at least bacterial? It's possible. But we don't know yet. The amount of space we've explored compared to the entire universe is even smaller than the water in a glass compared to all the oceans. We can't look at this tiny glass and say there's no other life in space. But we can't say definitively that there is either. What we should do instead of diving into fantasy and losing touch with reality is develop more tools to explore that vast ocean and increase the size of our glass. Because if there's life out there other than us, if extraterrestrial life is real, we'll find it sooner or later. Because truths have a way of coming out eventually.